In the last video, you were introduced to parametric equations, and what I want to do is go backwards now. I want us to already start out with parametric equations. That's what we have right here. And I want us to return back to a rectangular equation. So why don't you pause the video and try to figure that out? We want to take these parametric equations and go back to a rectangular equation. So an equation expressed in terms of x and y that we can plot on a Cartesian coordinate plane. All right, assuming that you've given it a go, let's get this done here. So essentially what we want to do is eliminate this parameter, or you could just say we want to kill the t. We want to get rid of all mentions of t here and just have an equation expressed in terms of x and y. And in order to do that, we can do all of these manipulations. We can solve one of these for t and substitute it in, or in other cases, we can use trigonometric identities. You're just going to get a ton of practice with this. But here, it looks like what we want to do, we can start playing around with something. We can look at this equation for y here, and we can subtract a 2, and then we'd solve for t, and then maybe we could just substitute that in. That looks like it might work. So let's do this. Y minus 2 is equal to t, and then we said, okay, hey, let's just substitute this in for what we have for our equation for x, our parametric equation for x. So we can now say that x is equal to 3, and then let's substitute what we had in for t. So this is going to be 3 times y minus 2 now, squared, and then minus 3. And you can see this right here is a rectangular equation. We have an equation expressed in terms of x and y. And what the nice thing about this is we can graph this now. This right here is a parabola. This is a parabola, and I've graphed it beforehand, and it looks something like this. So we can get a visual representation of what these parametric equations are saying.